Welcome back, Algebra 2 students, and in this video we are going to review vocabulary associated with relations. Now, in Algebra 1 we didn't focus on this particular word, we focused on a type of relation called a function, but in Algebra 2 we're going to expand things to include things that are not functions, so I'm going to make an emphasis on this word right here, relation. It is the set of ordered pairs, and that is it. It's just any set of ordered pairs. And the ordered pairs can be represented as an equation, a table, a graph, whatever. And we're going to definitely look at things that are not functions like the conic sections. Now, whether they are a function or not, any relation has a domain. And the domain is a set of all values of the independent variable, the input, or the x values. And any relation is going to have a range. It's the set of all values of the dependent variable that correspond to the values in the domain. And we think of these as the y values or the output values. Now I've chosen a very specific example, a relation to find the domain and range of. It is just a piece of what looks like a bigger function, but this in itself is a relation. And I can describe this relation in many ways. First, we're going to talk about the domain and range though. And I specifically chose this example to have an open endpoint and a closed endpoint, or a filled-in endpoint, to remind you of what these endpoints mean. Now, we learned about what they were with inequalities. And the open endpoint is an exclusive endpoint, meaning this endpoint is not included in the relation. It's just kind of like the start value. Now this filled in one, this closed one, is inclusive, meaning it is included in a part of the function. So this is a part of the function. And if I want to find the domain, I need to express all of the x values that are possible. And the x values that are possible are the ones between 2 and 8. So one way to write the domain is as an inequality with endpoints of 2 and 8. And since I'm talking about domain, it's the x values that range from 2 to 8. And I just need to pick the appropriate inequality symbol. Since this is an open or exclusive dot, it is a strictly less than. And since this is filled in, it is a less than or equal to. And you don't have to worry about the direction, whether it's less or greater, if you make this first number the smaller number and the second number the bigger number. Now, another type of notation you can use to express domain and range is interval notation, and that gets rid of the inequalities and uses parentheses and brackets. And if you remember interval notation, I use in parentheses to show an open or exclusive boundary, and then I'm going to use a bracket to show a closed or inclusive boundary. So parentheses for open, bracket for closed. And if your domain or range goes towards positive or negative infinity, the lemniscate, the infinity symbol, always gets parentheses. So this is another way to write the set of real numbers from negative infinity to positive infinity. Use parentheses for exclusive boundaries. Now, if I want to write the range, I have to be careful because the range are the y values. And it's not necessarily endpoint to endpoint because this particular function has its local maximum or its maximum value in between the endpoints or after that endpoint. So my range has a low value of 2 and a high value of 10. And since it's range, it's got to be the y values that change, not the x values. It's y for range. And then I look at the inclusivity of these two values. So at 2, it's included, so it's less than or equal to. And at 10, it's also included, and it's less than or equal to. And writing this in interval notation, it is an inclusive 2 to 10. Now let's talk about mapping diagrams. So a mapping diagram is just a picture that shows correspondence between two variables. And so I see that 1 maps to 5, 2 maps to 5, and 3 maps to 6. This first oval is the set of the domain, the second oval is the set of the range, and mapping diagrams are good to see if you have a function 1 And if you do have a function, what type of function is it? And we're going to learn about the different types of functions as we go through the function unit. But I know this one's going to be a function because each x value is going to map to a unique y value and not two different y values. And while I'm talking about functions, let's define it. A function is merely a relation for which there is exactly one value of the dependent variable for each value of the independent variable, which means one y for every x. And it must pass, if you remember, the vertical line test. And all the vertical line test is, it's just a test to see if something's a function. If I can draw a vertical line anywhere on the function, anywhere, it could just be in a single point of x values. If it hits the function more than once, it is not a function. So this relation is not a function because it has 3 y values for a single x value. Another thing we talked about with functions in Algebra 1 is function notation. Remember, we had the function name, in this case generic f. It could be whatever letter you want. It could match the context. So this f is the name of the function. That in parentheses tells you what the independent variable is. And this is the rule for the function. So it says the function value of x is 2x squared. And remember, this means exactly the same thing as y equals 2x squared. So f of x is the same thing as y. And so now there's a different type of notation that you'll occasionally see. It's called arrow notation. It's just like function notation, but it doesn't use parentheses. That f is still the name of the function. That is still the independent variable. And this is the rule, but it's read differently. This says that the function f takes x and it maps it to 2x squared. So x maps to 2x squared. So x becomes 2x squared on the y is what arrow notation means. I don't use this very often because function notation is more convenient. So one word I want to remind you of is asymptote. And asymptotes in Algebra 2 are going to be very important with the various types of functions, particularly rational functions. Right now, in the beginning of the year, an asymptote is going to affect our domain or our range. And an asymptote, by definition, is a line which a graph gets really close to but doesn't touch as x or y approaches a specific value. Now, that doesn't mean the function or a relation doesn't cross over the asymptote at some point, but it just means that at some value it approaches, it gets really, 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 really close to. So, for example, if I look at this function here, and this is a generic exponential function, so I can say like y equals 2 to the x. And this one has a horizontal asymptote that is the x-axis because the graph gets really, 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 really close to the x-axis but doesn't cross over it or touch it. It just gets really, 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 really close to it. And that is what an asymptote is. And this particular asymptote or horizontal asymptotes can affect the range. Because if I think about the range of this function or the possible y values, this function has a range that's y is strictly greater than 0. It can't ever equal, and that's what the asymptote does, is it tells you a value you can't equal in terms of range. Now, this is an example of a vertical asymptote, and you'll see that, let's say if I said this line here was x equals 4, you'll see that as the function or the relation approaches the value x equals 4, the y values approach infinity. And so this is an example of a vertical asymptote. Now these two don't cross over these asymptotes. They just get really, really close to it. And that means that there is a problem with the domain of the function, namely that the domain can't equal 4. So in this case, the domain is all the real numbers except 4. So vertical asymptotes tell you values that have been restricted from the domain. Now there's another type of asymptote that we're going to look at much later, and this doesn't affect domain or range, but it's one that's called a slant asymptote. And this is just some line that's not vertical or horizontal, so some linear function. is your asymptote, and then you have some graph that just approaches that line. And these only occur in very specific circumstances, and once again, they don't affect domain and range. And we'll talk about these much later when we talk about rational functions.